Welcome to our FAULHABER Drive Time. In this video, I want to give you an overview over the general approach how to configure the motion controller to use these analog inputs as the target values. Again, this is a few slides only in that case. The real hands-on experience is for the next videos. So let's have a closer look at these analog inputs. Important here, the scaling of these inputs is free. By using the filter and the offset and the gain, we can reach about every reasonable scaling here to use these inputs for either voltage, torque, speed or position. But please make sure to have the analog ground input of your controller connected to either the system ground or the negative output of your source, otherwise the input will be undefined. And then there's the complex one of these diagrams, that's the signal flow. In the center of the diagram, we do see this cascaded motor control, so current loop and then speed loop and the position loop. For all of them, the reference is either the next loop, or we can select to use a discrete reference by selecting the analog control mode, so either analog torque control, analog velocity control, or analog position control. If so, we would have to select the source to be used and think about the required scaling of this source, of course. Cascaded reference or discrete reference is always selected by selecting the operating mode here. Same for the feedback for the actual values for speed and position. Again, there is a software switch in position, but here the switch is always in use because we already did pre-select the used feedback by selecting the motor with the motor selection wizard in the beginning. So the parameters here are selecting the operating mode and selecting of the actual values, and if used, selecting discrete references. Now figure we want to use an analog value as the speed reference, and analog can either really be anything between minus 10 volt and plus 10 volt or a PWM signal, different setting then. We would have to select the analog velocity control, of course, and then select the source we want to use here and think about the scaling of the source. Same for analog position control. Again, select the analog control mode and select the source to be used and think about the scaling, and parameters here, again, operating mode and selection of the source. Now, about the scaling of these analog inputs. The raw input range is the full range of plus minus 10 volts, and this is represented by 10,000 digits within the control loop. So here the representation minus 10 volt would be minus 10,000. A value of 0, of course, ends up with a raw value of 0 plus 5 volt plus 5,000. I think that's quite obvious. These raw values can and have to be rescaled for your applications. Main parameter are the offset here and the gain. Additional ones would be the minimum and maximum values and the filter time, but let's stick with the main parameters here and do the scaling. First, there's the offset that we have to subtract from the raw input, and then the gain out of the numerator and divisor here. That's because you might want to have a non-integer scaling, but these parameters here, these two, are integer only. So if you want to have something like 2.5, you would have to select appropriate parameters to end up with the resulting gain here. Purpose of the scaling is to create a numeric value which can directly be used as the reference for the control loop, so either the target position in increments, or the target speed, which is then in RPM, or the torque, which is in a nominalized scaling where a value of 1000 equals the nominal torque of the motor. So let's do a first example. The input range would be the full range of plus minus 10 volt, and we want to generate a position target of 0 to 2700, representing the scale of such a potentiometer, so 270 degrees. First would be the offset, and let's start with a simple value. So let's use the minimum input, that would be the minus 10 volt with the minus 10,000 digits. And in that case, this should be end up with a value of 0 after the offset. So we have to use an offset of these minus 10,000 and would compensate this to the 0 here. Second, after we determine the offset, is to determine the gain. And when we now go to the maximum input value with the plus 10,000 of raw input here, we would add the offset, the 10,000 that we determined, end up with the 20,000 and want to generate a value of 2,700 out of this. And that's the equation here. So what we have to do is divide by the 20,000 and multiply with the 2,700. And then we are done and have the range of between the 0 and the 2,700. It's a little bit complex, but it's easier to see when we really do this live with the motion manager. So far, the general overview. In the next few videos, I will show you how to actually do this for either speed control or position control. But first, let's have a short break once again. And meanwhile, if you got any questions, of course, ask your local FAULHABER sales support or the MC support team, and check back with our channel and maybe leave a comment. Bye.